Here we have the infinite series n factorial square divided by 3n factorial, and we want to show that this infinite series converges. And we want to use the ratio test. And recall that to use the ratio test, we have to show for convergence, we have to show that the limit of a sub n plus 1 divided by a sub n is less than 1. And that's the objective here, is we want to show that this infinite series converges, and therefore we need to show that the limit of a sub n plus 1 divided by a sub n is equal to a number, finite number less than 1. And so this is a sub n right here. It's n factorial squared divided by 3n factorial. But n factorial squared is the same as n factorial times n factorial. And now we need to form a sub n plus 1. So a sub n plus 1, then in the place of n, we just put n plus 1. And then this is 3n times 1, so it becomes 3n plus 3. And then now we need the limit as n approaches infinity of a sub n plus 1. Divided by a sub n. So there's a sub n plus 1, and then this is a sub n. And then dividing by this is the same as multiplying by the reciprocal. And then we can rearrange the terms a little bit more. And notice that the n plus 1 factorial, that's the same as n plus 1 times n, and then times n minus 1, and then all the way down to 1. And then same thing here, this is the same as n, and then n plus 1, and then times n, and times n minus 1, and then all the way down to 1. And then this is n factorial, so that's going to be n minus 1, and then n minus 2, and then all the way down to 1. And same thing for this one. And then the 3n plus 3 factorial, that's going to be 3n plus 3, and then 3n plus 2, and then 3n plus 1, and then 3n, and then all the way down to 1. And same here, this will be 3n, and then the next one will be 3n minus 1, and then 3n minus 2, and then all the way down to 1. And then we just need to start simplifying. And so all of this n minus 1, then 1, that will cancel out with this. And then the n and the n minus 1 to 1, that will cancel out with the second part. And then this right here, this will cancel out with this. And so there's nothing here, so it means it's 1. And then over here, we can see that 3n, all of this, will cancel out with all of this. And so this is what's left. N plus 1 times n plus 1, that will be n squared plus 2n plus 1. And then all of this multiply together, be 27n to the third plus 54n to the second plus 33n plus 6. And then to find the limit here, we can divide everything by n to the third. So divide everything on the top by n to the third. And divide everything on the bottom by n to the third. So this will be 1 over n, and this will be 2 over n squared, and this will be 1 over n to the third. And this will be 27, and this will be 54 over n, and this will be 33 over n squared. And as n runs to infinity, all of this will go to 0, and then the bottom will get 27, which is 0, which is less than 1. Once again, for the ratio test, if we can show that the limit of a sub n plus 1 divided by a sub n is less than 1, then we can say that the series converges. And therefore, we can say that this series right here converges